Hello, good evening friends. My name is Anup Bhalla and I am teaching Quant and DI from last 11 years. Today we will discuss a session on number system. So we'll start the session on number system. Our first question is, what is the greatest power of 7 that will divide 100 factorial completely? So answer is 16. Most of you are called answer is 16. So let us check the answer. So we have to check the highest power of 7 in 100 factorial. Now 100 factorial, we have to check the highest power of 7. What we have to do, write 100 and divide 100 by 7 successively till the end. Like divide by 7, 100 divided by 7, 14. Again divided by 7, you will get 2. Now our questions are 14 and 2. So highest power of 7 in 100 factorial is 14 plus 2. That means this is 60. So answer is 60. So is it clear to everybody? Let us move to the next question. 167 factorial is equal to 5 raised to power p into y. What is the greatest value of p? Given y is not multiple of 5. So try this question. So Kamal is saying 0, Sumit 40, again Kamal 40. So most of them are giving the answer 40. So let us check the highest power of 5 in 167 factorial. This is the same as we did in the last question. So let us try 167. Divide 167 by 5 till the end. Successively divide 167 by 5 till the end. So 165 divided by 5, first comes at 33, then again divided by 5, this will comes at 6, then again divided by 5, this will come at 1. So our questions are 33, 6 and 1. The highest power of 5 in 167 factorial is 33 plus 6 plus 1. So answer is 40. So highest power of 5 in 167 factorial is 40. So answer is 40. Let us move to the next question. Find the smallest number that should divide 198 factorial so that it becomes odd number. So try this question. Some students are called Sumit, give the answer 185. Some students are called 2 raised power 194. What is the smallest number? So to make 198 factorial an odd number, we have to take common all the powers of 2. That means we have to take common highest power of 2 from 198 factorial to make it an odd number. So 198. So divide 198 by 2 successively. So 198 divided by 2. This is 99, again divided by 2. This is 49, again divided by 2. This is 24, again divided by 2. This is 12, and again this is 6. Next 3. Now next one is 1. So sum of these all the questions is 99 plus 49 is 148 plus 24, 172 plus 12, 184 plus 6, 188 plus 3, 1. This is 194. So highest power of 2 in 198 factorial is 194. So if we take common 2 raised power 194 from 198 factorial, it will become an odd number. So highest power of 2 in 198 factorial is 194. So answer is 194. Shubham, Afzal, Rahul, answer is 190. 2 raised power 194 to make 198 factorial as an odd number. So let us move to the next question. The highest power of 45 that will exactly divide 123 factorial. Option 1, 29, 2, 30, 31 or 28. Highest power of 45 in 123 factorial. Ashu gives the answer 28. Anshul gives 31, 32, but 32 is not the option. 4 is not the option, Kamal. So most of them you giving the answer 28. So let us start how to do this question. Now 45 is not a prime number, so first factorize 45 into prime numbers. This is 3 square into 5. So our highest prime divisor is 5. So we will check highest power of 123 factorial, highest power of 5 in 123 factorial. So again we will divide 123 successively divided by 5. So this is 24, then divide by 5, this is 4. So highest power of 5 in 123 factorial is 28. So highest power of 5 in 123 factorial is 28. So highest power of 45 in 123 factorial will also be 28. So let us move to the next question. Find the number of zeros at the end of the product of first 100 multiples of 10. Find the number of zeros. Number of zeros means highest power of 10, and if you want to check the highest power of 10, you have to check, because 10 is equal to 2 and into 5, so making it 10 you need 5 as well as 2, both are required, but highest power is 5, so you need to check it by 5 only. So 24, Damanpreet Singh, Ashu 24, Sumit 124, Hitesh. So 124, 24, 5050. So let us check the answer. So first 100 multiples of 10 would be 10 into 20 into 30 into 40 till 1000. So if we take 10 common, then 10 raised to power 100 is common, and remaining would be 1 into 2 into 3 into 4 till 100, which becomes 10 raised per 100. So highest power of 10 is 10 raised per 100 is 1, and the remaining 100 factorial. Now if we check highest power of 10 in 100 factorial, we have to divide 100 by 5. First 20, then again divided by 5, then 4. So 24 more. So highest power of 5, or we can say that number of zeros at the end of the product of first 100 multiples of 10 is 100 plus 24. Answer is 124. Maximum of you are calling the answer 124. That is correct. That is 124. So what we will do, first 100 multiples of 10 are 10 into 20 into 30 into 40 till 1000. If we take 10 common, then 10 raised per 100 is common, remaining would be 1 into 2 into 3 into 4 till 100. Now 10 raised per 100, that means 100 zeros are there first, then we will check number of zeros in 100 factorial, and number of zeros in 100 factorial is, we'll check it divided by 5. We will successively divide 100 by 5 till the end. So 24 more. So 100 plus 24, answer is 124. So let us move to the next question. What is the remainder when 17 raised to power 29 is divided by 11? So 17 raised to power 29 divided by 11. Now we can write it as 11 plus 6 raised to power 29 divided by 11. So this would be 6 raised to power 29 divided by 11. Now we know that 11 is a prime number. When divisor is a prime number, then the Euler number of that particular prime number is always, prime number is p, then Euler number is always p minus 1. So our divisor is 11, that means its Euler number is 10, that means its cyclicity is 10. We will divide the power by Euler number, 29 divided by 10, so we will get the remainder 9 by 11. Now 6 raised per 9 can be written as 6 cube into 6 cube into 6 cube. So divide by 11. Now 6 cube is 216. 216 divided by 11. Use the divisibility rule of 11. 6 plus 2, 8 minus 1, 7. Again into 7, again into 7. 7 into 7 into 7 by 11. This would be 343, and 343 by 11. 3 plus 3, 6 minus 4. Answer is 2 for this third option. So let us move to the next question. So next question is 2 raised to power 643 by 96. So okay, we'll move back to the previous question. In the previous question was find the remainder when 17 raised by 29 is divided by 11. Now 17 raised by 29 by 11, it can be written, 17 can be written as 11 plus 6 raised by 29 by 11. Now 11 divided by 11, remainder would be 0. So remaining would be 6 raised by 29 by 11. Now 11 is a prime number, so Euler number for prime number is always prime number minus 1. So cyclicity of 11, or we can say that Euler number of 11 is 10. Now we divide the power by the cyclicity. 29 by 10, remainder would be 9. So 6 raised by 9 can be written as 6 cube into 6 cube into 6 cube. So 6 cube 216, 216 by 11 we'll see, we'll use the divisibility rule of 11, that is 6 plus 2 minus 1, 7. So 7 into 7 into 7 comes out to be 343 by 11 is equal to 2 by 11. So remainder would be 2. See Kamal, this is not 3 plus 3 plus divisibility of 11 is what? It is difference between the sum of odd position digits and even position digits should be 0 or multiple of 11. Now odd position digits 3 plus 3, 6. Even position digit there is only 4. So 6 minus 4, 2 by 11, remainder would be 2. So this is divisibility rule of 11. So let us move to the next question. This is 2 raised by 643 by 96. Hitesh, this is not 8. Answer is not 8. Adi is giving 32. Nikhil 32. So answer of this question is 32. So let us check how 32 is the answer. So 2 raised by 643 divided by 96. Now we know that 2 and 96 are not co-prime to each other. So we have to simplify this to make the numerator base and divisor co-prime to each other. So 2 raised by 643 can be written as 2 raised by 5 into 2 raised to power 638. Divide by 96 can be written as 2 raised by 5 into 3. So we can cancel 2 raised by 5. Remaining would be 2 raised by 638 divided by 3. So this 2 can be written as 3 minus 1 raised to power 638 divided by 3. Now this 3 is divisible by 3, so remainder would be 0. So we will remain with minus 1, and minus 1 raised by 638. 638 is an even number, so minus 1 raised by even number, remainder would always be 1. So 1 by 3. So if we divide the numerator by 3, remainder would be 1. But in our question, divisor is 96. To make the divisor 96, we have to reintroduce 32. We have to multiply the numerator and denominator, which we simplify in the starting stages. We have to reintroduce 32. So multiply and divide the numerator and denominator by 32. We will get the answer 32 by 96. That means if we divide this number by 96, remainder would be 32. So answer is 32 for this question. So let us move to the next question. See, Priyanshi, we have to reintroduce 32. Reason our divisor was 96. So in this case our divisor is 3 only. To make it 96, we have to, which we simplify in the first stages, starting stages, we have to reintroduce 32 to make the divisor 96, not the 3. Answer is 32. So let us move to the next question. This is 5 raised to power 13 raised to power 14 raised to power 17 raised to power 21 by 6. So what should be the remainder? For the basics of the Euler number concepts, you can watch the video on YouTube at hitbullseye.com. So all of them are saying the answer is -1 or 5. -1 or 5 1 and the same thing. Minus 1 is the negative remainder and 5 is the positive remainder. So for this question, 5 raised to power 13, raised to power 14, raised to power 17, raised to power 21 by 6. Now 5 can be written as 6 minus 1. Now power is 13 raised to power 14 raised to power 17 raised to power 21. See, 13 raised to power anything, 13 is an odd number, so 13 raised to power anything will always be odd. Now 5 can be written as 6 minus 1 and power is odd. Now 6 divided by 6, remainder is 0, remaining is minus 1 raised to power odd. Minus 1 raised to power odd is always minus 1. So remainder is, negative remainder is minus 1 or positive remainder is minus 1 plus the divisor, remainder is 5. So our answer is for this question is 5. So let us move to the next question. Find the last digit of 7 raised to power 11 raised to power 12 raised to power 30. What is the last digit of this? So for the concept of last digit, we have to check the cyclicity of each digit. Cyclicity means after how many steps the last digit is repeating itself. As all we know that cyclicity of 7 is 4. So we have to divide the power by the cyclicity, and power is 11 raised to power 12 raised to power 13 divided by 4. Now 11 can be written as 12 minus 1 raised to power 12 raised to power 13. Now 12 raised to power 13 is what? Even or odd? 12 is even. Even is per anything. The answer would be even. So answer is 12 minus 1. We can write it as even divided by 4. Now all we know that when 12 is divided by 4, remainder would be 0, so it remains minus 1, and minus 1 is per even is always 1. That means remainder is 1. Now we can write this remainder is remainder 1 instead of all the power 11 raised per 12 raised per 13. We can write it as 1. So 7 raised per 1, last digit would be 7. Cyclicity basically means after how many steps 7 is repeating its unit digit. Like we can say that 7 raised per 1 is 7, last digit. 7 square 49, last digit would be 9. 7 cube 343, last digit would be 3. And 7 raised per 4 is 2401, that means last digit is 1. Whenever 1 comes, that means cyclicity ends itself. So our cyclicity is 4, that is 7931. So we divide the power by 4 and get the remainder 1. We write the remainder 1 instead of the power. So 7 is per 1. The last digit would be 7. For the basic concepts of cyclicity, you can watch the video on YouTube on Hitbullseye.com. Find the remainder when 63 raised to power 63 raised to power 78 is divided by 10. What is the remainder? So maximum of you are giving the answer 3. So let us check the answer. 63 raised to power 63 raised to power 78 by 10. See, whenever a number is divided by 10, the remainder will always be the last digit. Unit digit will always be the remainder. In other case, we can say that whenever a number is divided by 100, the remainder will always be the last 2 digits. So in this case, we are dividing the number by 10 and we want to find the remainder. So in this case, we just only check the last digit of this number, because when this number is divided by 10, remainder is always the last digit. So let us check the last digit of the 63 raised to power 63 raised to power 78. Now the last digit is 3. So cyclicity of 3 is 4. So if we divide the power is 63 raised to power 78. We divide the power by 4 and check the remainder. Now 63 can be written as 64 minus 1 raised to power 78 by 4. Now 64 is divisible by 4, that means remainder is 0. Now we remains with minus 1 raised to power 78. 78 is even number, so minus 1 raised to power 78, remainder will be 1. So we can write the remainder instead of the powers. So powers are 63 raised to power 78. We can write 1 instead of this. So 63 raised to power 1, the last digit would be 3. So answer for this question is 3. I hope that all of them are getting this. Okay, let us start with the next question. Find the last 2 digits of the product of this. Last 2 digits of the product of 521 raised to power 125 into 125 raised to power 521. So options are 75, 25, 45 or none of these. Let us start this question. 521 raised to power 125. Now all of us know that if any digit ended with 1, the raised to power anything, the last digit would be 1 only. For the second last digit, you have to multiply the unit digit of the power to the second last digit of base. Now unit digit of the power is 5 and second last digit is 2, so 5 into 10, 5 into 2, that is 10. So we will write 0 1, last 2 digit would be 0 1. In the case of if any number ended with 5 and there is an odd number before 5, raised to power odd. Now these two odds can be same and can be different, but this odd number should not be equal to 1. In maximum cases 1 should not be there. So these two odd may be same, may be different. The last 2 digits of this always be 75. Otherwise, if there is an even number before 5, power odd, or there is an even number before 5 and power is even, and there is an odd number before 5 and power is odd, even again, in these 3 cases the last 2 digits would be 25. Now in this question, second part is 125 raised to power 521. As we know that there is 12 before 5, which is an even number, and power is odd. So in this case the last 2 digits would be 25, and 25 into 0 1, the last 2 digits would be 25 only. So answer is 25 in this question. So let us start with next question. Find the number of factors of 6 times 5. See, for the basics of last 2 digits, please watch our videos on YouTube at hitbullseye.com. So our next question is number of factors of 555. So 62, Rahul says 62, someone says 32, 64, 128. So try again. What should be the answer? 2 raised per 6, that means 64, 6 only. 32, someone says 16. Okay, so someone wants to ask a question, please ask. So what is your query? Please ask. Answer is not 2 raised per 57, raised per 38, raised per 39. What is your exact question? Please ask. Now let us move to this question. So someone wants to show the last slide. This is the last slide. Shibashish, please ask your question from the last slide. So no question. Let's move to our question, that is find the number of factors of 555. For the number of factors of any number, first you have to prime factorize that number. Suppose number is n, you have to prime factorize it, like a raised to power p into b raised to power q into c raised to power r. So number here a, b, c, these 3 are prime numbers. These 3 are prime numbers. So 555, if we prime factorize 555 and 555, this will gives you 5 into 11, 111 into 1001. Now 111 further factorized into 3 into 37, and 1001 can be further factorized into 7 into 11 into 30. So there are 6 prime numbers and power of each prime number is 1. So number of factors for 6 times 5 are 1 plus 1 into 1 plus 1 6 times. So this will gives you 2 raised to power 6. That means answer is 64. So answer for this question is 64. I guess all of you are getting this. So shall we move to the next question? So our next question is, now someone is asking about the unit digit of 2 raised to power 59 raised to power 37 raised to power 43 raised to power 36. So let us do this question. 2 raised to power 59 raised to power 37 raised to power 43 raised to power 36. Now cyclicity of 2 is 4. Now divide the whole power by the cyclicity. This is 59 raised to power, now 37 raised to power 43 raised to power 36. This is an odd number, so we can write 59 raised to power odd divided by 4. This can be written as 60 minus 1 divide power odd by 4. Now 60 is divisible by 4, remainder would be 0. So minus 1 raised to power odd is minus 1. So remainder will be minus 1, or minus 1 plus 4, 3. So we can write the remainder instead of the power. The 2 cube, the last digit would be 8. Shravani is asking how odd number. See Shravani, 59 is an odd number, and raised to power anything, odd raised to power anything is always odd. So we will write it here odd. How the power is odd for 59? See, 59 is an odd number, and odd number raised to power anything will be odd. So odd into odd or odd raised to power odd is always odd. So answer is 8. Let us move to our next question. To reach bullseye, a student has to take 100 steps. He can take steps of 3 or 5. He can take at a time 3 steps or 5 at a time. How many different steps of 5 can he take if he must take at least 1 step of each time? Let us try this question. Gopi, answer is 47, and someone is giving the answer 6. So what should be the answer? Try this. Vamsi is giving 6, Harish 21, so Onkar 20, so 99, 17. Please read the question carefully. Read the question carefully. He can take 3 steps at a time or 5 steps at a time. So how many different steps of 5 can he take? This is the question. See, let us do this question. Number of 3 steps. So let us take number of 3 steps. Suppose this is x, and number of 5 steps. Suppose this is y. Now we know that 3x plus 5y is equal to 100. So that means y is equal to 100 minus 3x upon 5. Now we know that 100 is divisible by 5, so we have to make the values of x such that 100 minus 3x divided by 5 gives you an integer. So if we take go by hit and trial x 5, then y would be equal to 100 minus 15 by 5. Y would be 17. Now next value of x, where we will get 100 minus 3x over 5 as an integer, this will be at a difference of at least 5, because we see that we divide 100 minus 3x by 5. So difference between these two different values of x would be 5. So next value should be 10, and y is equal to 40. Now we see that x is increases by 5 and y decreases by 14. Now we'll just next value is x is equal to 15, so y will be dropped by 3 यानी कि 11. If x is equal to 20, then y would be equal to 8. If x is equal to 25, then y would be equal to 5. And if x is equal to 30, then y is equal to 2. After this, y will have negative value. And so there are only 6 cases possible. So our answer should be, how many different steps of 5 can he take, and that should be 6 values. So answer should be 6. So anybody having any problem in this question, you may ask. Okay, shall we try next question? So let us move to the next question. A hockey team is in a certain year is played 45 games. The team has never lost 3 games consecutively, never won 5 games consecutively. If n is the number of games won by the team, then what should be the range of n? First option, n is greater than or equal to 12 but less than or equal to 42. Second option, greater than or equal to 15, less than or equal to 36. Third, greater than or equal to 14 and less than or equal to 38. And fourth option is greater than or equal to 10 and less than or equal to 40. So try this question. What should be the answer? Shubham answer 2, Harish 2. Most of you are giving the answer 2. So let us try this question. Now we know that he can win at the most 4 games consecutively, not fifth one, and he can lose 2 games consecutively, not third one. So let us get the best scenario. Maximum wins कितनी हो सकती है? Let us try this. So for maximum wins, he will win 4 in a row and lose 1 after this. That means out of 5 games, he win 4 games, and total number of games 45. So number of wins at the max can be, number of wins at the max is equal to 4 out of 5. So out of 45, he can win at the max 36 games. And if he lose consecutively, or for the worst scenario for value of n, he can lose 2 games consecutively and 1 win. That means out of 3 games, he can lose 2 and 1 win. So number of wins in the worst scenario is 1 out of 3. That means out of 45, this should be 15. So minimum wins would be 15 and maximum would be 36. So answer should be second option. So is it clear to everybody? Ashu, see, for the maximum wins, he will win 4 games consecutively in a row and lose 1 game, because he cannot win 5 games consecutively. So for first 4 wins, he lose next 5th one. For the next 4 one, he will lose next 10th one. So out of 5 games, he wins 4 games. So out of 45, he wins 36 games. And if wins will be minimum, then he loses maximum. That means he can lose 2 matches in a row, and next should be a win. So 2 loses, 1 win. So out of 3, he can win 1 match. So total number of wins should be 1/3 of 45. That should be 15. So answer should be second option, where n should be greater than or equal to 15 and less than or equal to 36. So let us move to the next question. The sum of 3 positive numbers is 3 times one of the numbers. The product of the least and the greatest is 261. How many such number sets are possible if all numbers are less than 100? So try this question. Options are 1, 2, 3, 4. Very close options. So try it. So answer is 2. Second option. Try this again. Read the question carefully, please. So let us try this question. Sum of three positive numbers is 3 times one of the numbers. The product of least and the greatest. Least and the greatest. So least number and greatest number, their product is 261, which can be written as either 3 into 87 or 9 into 29. There are only two possibilities, 3 into 87 and 9 into 29. If you want to get the third number, you can get, as we know that third number thrice of the number is equal to sum of the three positive numbers. Suppose, and first case we will get 3 first number, second suppose x and 87, so x would be equal to 45. If we check second option, we will get 3x is equal to 9 plus 29 plus x, so x is equal to 90. So only two options are there. Now Gaurav is telling 1 into 267. If we will take least into greatest, 1 into 287. This cannot be taken as 1 into 287 because all the numbers are less than 100. There are two options, 3 and 87, 9 and 29. Answer should be second option only. So let us move to the next question. If n is equal to 3 cube into 5 square, and if n is equal to a into b, such that a and b are distinct natural numbers, find the number of sets of such two numbers when neither of them is a perfect square. So a and b both should not be equal to a perfect square. So try this. So option 3, option 4. Please read the question carefully. Ashu, option 3. Please read the question carefully and then start trying this. So let us try this question. Now n is equal to a into b, where a and b should not be perfect square. So in this case, n can be written as 3 cube into 5 into 5 first number, or n can be written as 3 square into 5 into 3 into 5. That means one number is 3 cube 27, 135 into 5. Second way is this is 45 into 15. So only two possibilities are there. So answer should be first option. Only two ways are there. That is 135 into 5 and 45 into 15. You cannot reverse this because question is asking about the number of sets. Number of sets is basically ordered pairs. So number 135 into 5 and 5 into 135 are the same thing. 45 into 15 and 15 into 5 are the same thing. In this question answer, there are only two pairs. First option. So let us move to the next question. If a charismatic number n is defined in such a way that n is either equal to m square or this is equal to p cube, that means it is equal to a perfect square or is equal to a perfect cube, but not both. But not both means number should not be in the form of a raised to power 6. That means power should not be equal to 6. So it can be a perfect square, but it cannot be in the form of a raised to power 6. It can be a perfect cube, but it cannot be in the form of a raised to power 6. It can be m square, but it cannot be in the form of m raised to power 6. It can be a p cube, but it should not be in the form of p raised to power 6. So how many numbers are there from 1 to 10,000? Try this. 112. Sunil saying that answer is 112. So options are 112, 116 and 124 and 128. So someone says the answer is 124. Try it again. So try it again. Please read the question carefully. Number should be in the form of m square, but it cannot be m raised to power 6 because number should not be a perfect square as well as a perfect cube. So number should not be in the form of m raised to power 6. Number can be a p cube, but it cannot be in the form of p raised to power 6. So let us try how many squares are there till 10,000. So till 10,000, m square can be 1 square, 2 square, 3 square till 99 square. So 99 numbers, but number which are in the form of m raised power 6, that means 1 raised power 6, 2 raised power 6, 3 raised power 6, 4 raised power 6 should not be there. So minus 4 numbers. So there are 95 numbers from 1 to 10,000 which are a perfect square but not perfect cubes. So let us check how many cubes are there. So p cube can be 1 cube, 2 cube, 3 cube till 21 cube. So there are 21 numbers, but number should not be in the form of p raised power 6. So number should not be 1 raised power 6, 2 raised power 6, 3 raised power 6 and 4 raised power 6. So there are which are only perfect cube. There are 21 minus 4. There are 17 numbers which are only perfect cubes. How many squares? 99 squares from 1 to 99, but number should not be m raised power 6 form. So 1 raised power 6, 2 raised power 6, 3 raised power 6, 4 raised power 6 are eliminated. So 95 perfect squares which are not perfect cubes, and there are 17 perfect cubes which are not perfect squares. So total numbers are 95 plus 17, 112 numbers are there. So answer is 112. We did minus from both the cases because in first case we are mentioning only perfect squares, not perfect cubes. So we have to minus numbers which are in the form of m raised power 6. So total 99 squares are there, minus 4 which are in the form of m raised power 6 is equal to 95. Likewise there are 21 cubes, but there are some numbers which are in the form of p raised power 6 which are perfect cube as well as perfect square. We will not count these numbers, so we will minus 1 raised power 6, 2 raised power 6, 3 raised power 6 and 4 raised power 6 from the perfect cube. So we will get 17 numbers there. So total numbers which are perfect squares or perfect cubes are 95 plus 17, 112. So answer is 112. I think you are getting this. We are not subtracting the intersection part. In both the cases, question is asking only for perfect square, not perfect cube. So we have to minus the perfect cube part. Likewise, in the second question, he is asking only for the perfect cube, not numbers which are perfect squares. So again, we have to minus 4 numbers from the perfect cubes. So 112 is the answer. 1 is subtracting twice because 1 is a perfect square as well as it is in the form of 1 raised power 6, and 1 is a perfect cube but it is as well as in the form of 1 raised to power 6. So we have to subtract 1 twice because we don't want any number which are perfect square as well as perfect cubes. So we have minus 1 from the both the numbers. So this is the question. I hope all of you are getting it. Shall we start the next question? So let us move to the next question. If we write down the digit 5 side by side 777 times, we get a large number of 777 digits. If this number is divided by 101, what will be the remainders? And options are 0, 5, 50 and 96. So try this question. There are 777 fives and it is divided by 101 and we have to find out the remainder. Please read the question carefully again and then solve the question. Don't do the silly mistakes. Read the question carefully. So what should be the answer? Sunil is 0, then Joy 0, Saurabh 0, Damanpreet 47. So before doing this question, let us know the divisibility rule of 101. Now suppose there is a number that is 1, 2, 3, 4, 5, 6, 7. Now we have to check this. Is this number divisible by 101 or not? For the divisibility of 101, we have to make a pair of 2 from the unit digit. 67, then 45, then 23, then write a 0 with 1 and 0, 1. Divisibility rule of 101 is same as 11, but there is a difference between these two. The divisibility rule of 101 is difference between the sum of odd position digits and even position digits taken 2 digits at a time should be 0 or multiple of 101. I am repeating this. We have to make pair of 2 from the unit side. Then difference between the sum of odd position digits and even position digits taken 2 digits at a time should be 0 or multiple of 11. So now 67 is at odd position. Alternate of 67 is 23. So 67 plus 23 is 90. Now alternate of 45 is 0, 1. Now 45 plus 1 is 46. Now difference of these two is 44. Now 44 is not divisible by 101. So answer is remainder in this case is 44. Now in our question, if we make pair of 5, this is 777 digits. If we make the pair of 2 from the unit digit, we'll see that there are 388 pairs of 55 and 15 remaining. So there are 388 pairs of 55. In that case, we know that at odd position there are 194 pairs of 55 which is at odd position, and there are 194 pairs which are at even position. So 194 pairs at odd minus 194 pairs at even position taken 2 at a time. So difference will be 0 and there is only 15 remaining in this. So 5 divided by 101, remainder would be 5 only. So 101, what we have to do, we will make pairs of 2 digits at a time from the unit digit. We see that there are 388 pairs of 55 and 15 is remaining. There were 194 pairs at odd position and 194 pairs at even position, and difference between the sum of these two is 0. Remaining there is only 15 and this 5 is divided by 101, remainder is 5 only. So answer is 5 for this question. So this is end of our session. I hope you got the solutions of all the questions and there will be no problem for you. For the basic concepts of numbers, you can always visit our site hitbullseye.com. You can see the videos from YouTube at the rate of hitbullseye.com. So this is the last question for the session. Thank you for the session and all the best for your exams. Thank you very much.